Hello viewers, this is Harinath. Welcome to my new YouTube channel, and in this video I'll be discussing about how to use HFSS software for an antenna design and what are the basic steps to be followed to design an antenna. Okay, this software that I'm using for designing is HFSS 13 version, and I'll be teaching you now what are the different components that you use and different tools that you use in this software to design an antenna. Okay, let's start. And this is the first page that you get displayed in our HFSS software, and on the top left corner you can see insert HFSS design. So this is the first step that you should be that should be followed in designing. When you click on it, uh, a page will be displayed like this with the axis called X, Y, Z, and on this axis, considering this axis, you'll be designing a antenna. And there are different tools that you use here, and I'll explain briefly what are the tools and how to use these tools. Okay, the first thing is that the box, you can see here a box and a cylinder and a polyhedron, then cone, then sphere. And there are totally six tools, and these six tools, apart from these six tools, you'll be using only two tools mostly. That is box. The box is used for drawing the substrate alone, and ground and patch also you can draw using box, but I'll tell you what are the disadvantages by using this box for a ground and patch. Next is cylinder. This cylinder you will be giving to give the coaxial feed to the antenna, and that's all. And the remaining not that much important, we will not be using mostly. And the next thing is a rectangle, circle, polyhedron, ellipse, and uh, that's not then these four you'll be using to draw the patch. And patch can be of any shape, but mostly in microstrip patch and now you'll be using rectangle, then later you'll be using circle only, but polyhedron also you'll not be using mostly. And these are the two tools that you use mostly in the for designing the patch. And the next thing is you can see four options here: unite, subtract, intersect, and split. Apart from these, and last is imprint. Apart from these five, you will be using only two mostly. One is unite. If you want to unite two components or two rectangles, something, two patches, different patches in the antenna, you'll be using an option called unite. I will show you how to use this unite option in the later. Then next thing is subtract. Suppose if you want to include something like rectangular slot on the patch, you'll be drawing the rectangular slot there, and from the patch you'll be using this option to subtract a particular different shapes in them on the patch. And intersect alone you'll not be using more, this only these two you'll be using mostly. And the next thing is here you can see a material called, you can directly select material from here like this. You can choose various material for a substrate. Only for the substrate alone you will be using the material, and that you can do it here directly. I'll show you later how to use this also. Then there is a hand like structure called pan. Using this pan you can move your antenna like this for perfect weave. You can move side by side, and then beside that is rotate around model center. Suppose if you want to see the ground plane, you cannot see properly from the top view, so what you do is select that option, so you can rotate it so that you can have a perfect view of each and every side of the antenna. And that's all. And the remaining two you'll not be using mostly, and these two you'll be using mostly. And that's all about the components. There is nothing more to explain it. And suppose if you want to go back to the step, suppose to the previous step, what it is, there are option called here undo and redo, so you can simultaneously you can choose based on your requirement. And that's all. And you can select units also. Mostly in HFSS you'll be using the units that you use because in a micro millimeter only you will be drawing the antennas, because micro, so this type of antennas are of very little small size, so mostly you choose the units as and based on your requirement you can choose different solution setup also. I'll show you HFSS. um, HFS boolean HFSS. And based on your requirement you can choose units also. Go to modular units, then you can choose different types of units, like a centimeter based on your current, but mostly better to use millimeter only. Okay, that's all. And that are the only tools to discuss, and if any new tools to discuss, I'll discuss that later. Okay, as of now we'll start the basic design. But for an antenna design, the first thing you should keep it in mind in that, suppose if you want to design antenna, the first thing is that you have to choose a desired application, particular application, and that particular application you have to choose a frequency. Suppose I want to design antenna for a satellite application, so I have to uh, re-verify that at what frequency I have to design the antenna so that it can work for a satellite application. So as of now I'll not be showing that, first I'll be showing the basic design, and later session I'll be designing antenna based on the equation, based on the application I'll show you, and what are the tips to be used and the techniques to be used to uh, get a good result for a particular antenna. Okay, now the first, there are three components mainly that should be used in antenna. First thing is substrate, the next thing is ground, then the next thing is patch. Always patch is in the middle between ground and the patch, and patch is on the topmost of the substrate, and the ground is lowermost part of an antenna. So these are the three most basic components of an antenna. In every antenna design, these are the compulsory components. So first you'll draw the substrate. For the substrate alone you will be using the box. So click on box, place it at the center, then drag it and take this little bit up. That this is the box. Okay, for box alone you'll be assigning material, that I'll tell you. For this box alone you name it as substrate, so that you can easily identify that particular component is substrate and it is a ground, like that. Okay, substrate. Then the main thing that you have to consider while drawing a substrate is that you have to give the thickness, because depending on the thickness also your results, antenna results may vary. So as of in a market, the thickness of the substrates that are available is 0.8, 1.6 and double of the 3.2. In this format substrate thicknesses are available. So as of now I'll be using 1.6. Mostly everyone will be using 1.6 mm, but for the simulation purpose alone you can use any type of thickness you want. But if you are going for a fabrication and for a testing, you should always use a particular thickness of the substrate only. And here it is 2.2 and 3.2. Let's take something 17 or 21. That's right, but these are the not the exact values that I'm giving dimensions. Okay, ground substrate is over. Next thing is ground. For the ground alone you have to choose rectangle. So draw the rectangle. Okay, Now the thing is, your ground should be always at the bottom, but now it is on the substrate. So what you do is, before that, name it as ground for your identification, then change the dimensions. Now here the position of the ground is given 0 0 1.6. The thing is, it is on the substrate. So our ground should be below the substrate. So what you do is, when you give position as 0 comma 0 comma 0, that will automatically go down to the origin that is below the substrate. See, you can see it, the pink color is ground now. And the next thing is patch should be always on the top of the substrate, and it substrate is sandwiched between the patch and the ground. Now for patch also, you can choose any of the tools that are used. Either you can choose rectangle or circle or a polyhedron or ellipse. As of now, I'll be using rectangle. So see that or your patch always should be symmetric to the substrate. Okay, now as you can see, when you view from this side, it patches viewed that it is on the top of the substrate, but it's not like that. It is in the ground, on the ground. The patch is now, the patch has gone to the substrate, but according to the antenna basic components arrangement, patch should be on the substrate. So what you do is, before that, name this rectangle as patch, and change your dimensions. It is 4 comma 6 comma 0. 0 in the sense the position in z axis has been gone to the ground. So what do you the thing is that the ground patch should come onto the substrate. The thickness to the substrate we have given is 1.6 mm. So when you give 1.6 mm, it will automatically come onto the substrate. You can see. So okay, we have completed the basic components in antenna. Now the thing is, I have to give an excitation to this antenna. So for giving an excitation feed in the sense feed, I have to create a transmission line so that the feed that I am giving should travel through the transmission line to the patch. So that I'll be drawing a feed line. Click on the rectangle, then draw the feed line. See that your feed line is also exactly symmetric to the patch. Okay, as if like we cannot draw this transmission line patch and all. For this also we have to follow the uh, design equations. So that feed also has gone to the ground, you can see it. So what you does is, before that, name it as feed, and that has gone to ground, so that when you give 1.6, that will come on to the substrate. Yes, it has come. Now the thing is, I have said at the starting of the video an option called, at the starting of this video, an option called unite. So that unite will be applicable here. This patch and a feed line should be united so that a proper impedance matching is up. So proper impedance matching takes place. So what you do is, click on the patch, then select the transmission line, click on unite, and you can see both are united. So when these get united, there is a possibility for perfect impedance matching, so that whatever the power you give, that will directly go to the patch instead of reflecting back. Okay, I have drawn transmission line, patch, ground and substrate. Now the thing is, I have to create a source so that I can give excitation and I can allow excitation from that to flow through the transmission line. So what I do, I need a rectangle in XZ direction. In XZ direction axis, I need a rectangle. So what I do is, I can choose here, there is option called, you can choose any axis here directly. So click on XZ. So when I choose that, I can draw a rectangle like this so that I can give feed through here. You can see here. Okay, that's all. Okay, all the basic components have been over. Now the thing is, whatever the rectangle box I have drawn is of wasteless now, unless and until I assign something to that. So now the thing main step that we have to follow is that each and every component that we have drawn here should be assigned something. If you are assigning only, the software will take it as this is ground, this is patch, and this is substrate. Unless until you doesn't assign something, it's of wasteless in this software. So what you do is, for ground and patch alone, you'll be assigning the boundaries. So what you do is, because those both ground and patch are the perfect conducting materials. Now we know that it is a perfect conducting material, but how do the software knows? So what you do is click on the patch, right click, assign boundary, perfect T. So when you give perfect T, this will be considered as a perfect conducting metal, that is copper. Then similar way for ground also, right click, assign boundary, perfect T. So now it is, what does that mean is that both patch and ground are perfect conducting materials when you are assigning the perfect boundary. So you change axis to normal xy before that. Now the thing is box, substrate. The antenna results will also depend mostly on the type of the material you use, but most of the by default it will be taken as vacuum as a material. But in antenna design, mostly most of the authors will be using antenna designers FO for epoxy, that is flame retardant. Flame resistant is a flame resistant material. So they use this material because it is cheaply available in the market, so mostly they'll be using FR for epoxy. And other than this, we can use any type of material, but we should see that this particular antenna is well good working order for this when you assign this type of material. And apart from FR4, there are many materials called Rogers, mostly antenna designers will be using antidiroid material, that is called Rogers. Mostly they'll be using 5800, and as of now we'll be using FO for epoxy, that is flame resistant, which has a relative permittivity of 4.4. Okay. Okay, now we have assigned boundary to the patch, then ground, then material to the substrate. The thing that we have left is that we have drawn one more rectangle here, but we didn't assign anything to this material. So what you do is, for this we have to assign excitation. So right click, assign excitation, and you can see there are many types of ports: wave port, lambda port, frequency port, instant. But mostly for an antenna design microstrip patch antenna, you'll be using either wave port or lambda port. And the difference between these two is that when you're using the lambda port, we'll be getting a better performance result, so we'll be using the lambda port. So lambda port, next new line, draw the feed. If your feed is perfectly assigned, the message will be displayed called define. If not, it will be displayed as invalid. So our basic design is over, and you can recheck. There is a option called validate. Here what it does is, when you validate that, it will show tick marks with a green color. If anything is invalid, that will be shown in the cross mark. So the thing is that analysis setup. What is analysis setup is that I know that I have designed this antenna for a particular application, but how do the software knows? So you have to assign the analysis setup, the frequency, at what frequency you have designed this software. So before that, I have to draw a box. I have to create an environment called air environment to this antenna. I have drawn a box, and we should always see that the antenna should be placed at the middle of this box. We can create transparency to this box so that you can watch whether the box has been perfectly placed at the middle or not. Okay, perfect. It is at the middle, and the main purpose of this box is that here it is a box, and for box we have to assign material called air. I am creating a environment called air medium to this antenna, because when a patch antenna radiates, that is when patch radiates, that patch radiations, depending on the patch radiation, the results are validated. So when I create a box, the radiations will be uh, mm, limited to this box, and depending on this box, the radiations are the radiation patterns and the result radiation pattern, that is the gain of the antenna, can be calculated. If this box is not given, you cannot find the gain of a particular antenna, because the radiations that patch the when the patch radiates, that radiations have to go have some medium to pass through. So in the software we have to create a medium called air medium, so that the patch radiations will be limited to this box, and the results are calculated like gain, directivity. And for this box also you have to assign boundary. Instead of perfect, you have to assign radiation. That's all. Now we can validate here. And analysis setup, we should do analysis setup. Click on this analysis, right click, add solution setup. Now suppose just for a simply I can give 7 gigahertz, because I didn't choose any particular application for this. Just it is a basic design. So just I have given 7. Take a number of passes 20, so that number of iterations gives better result. And analysis setup, right click, add frequency sweep, and this and all. Here give steps is around 0.01, so that your results will be obtained very fast. Now you can check it, all the or in tick mark. So, and this is the basic design steps. As for every antenna, this is the basic components, and these are the basic steps to be followed. And suppose if you want to design a creativity antenna, your patch should vary and your patch should be unique from other antennas, and that is the only thing that you have to modify in any antennas. That's all, guys. And this is the thing. Later I'll be discussing the perfect antenna design. This is to show basic alone I have to draw on this, and these are not the perfect dimensions that I have to in this time antenna. And later session I'll teach you how to design antenna using the equation for a particular frequency around. And later sessions I'll be